Okay, let's start off with a song. This is the Pythagorean Theorem song. I just wrote it. Here's how it goes so far. A squared plus B squared equals C squared. C must be the longest side, and it's always across from the little box we call the right angle. And C usually looks like a slide. One more time. A squared plus B squared equals C squared. C is always the longest slide, and it's always across from the little box we call the right angle. And it's also the side that looks like a slide. So there you go. That's the Pythagorean theorem. This is one of the most important theorems, most useful theorems in math. Carpenters use it. It's very easy to use because you can often have right angles. Look around your room and you'll see that the walls meet at a right angle. The floor meets at a right angle. They're all over the place. And all you have to do is draw a connection between the two walls, and voila, you have a triangle. And not only is it a triangle, it's called a right triangle. A right triangle is a triangle with a right angle, which is a 90-degree angle. A right angle implies a 90-degree angle. Okay? So we have this theorem called the Pythagorean theorem. And it's right here. A squared plus B squared equals C squared. What does this mean? This means that if we know two sides of a right triangle, we can easily figure out the third side. Like, that's really profound. Okay, that we could find a missing piece of information by doing some math. So let's go. Okay, so we're gonna you should have all this in your notes, but I'm gonna clear it and start from the beginning of what I was saying. So we have our right triangle. Draw that nicely, nice sharp corners in your notes. Don't do one of these. I mean, like, what is that? That's not a triangle. Right? Come on, draw a triangle, Some people. Okay, so now we're going to label the sides. First thing we're going to do is label sides A, B, and C. These are the success criteria, right? I can, label sides A, B, and C. Can you label the sides A, B, and C? So where do they go? I'm going to put A there, B there, and C here. And guess what? You can do that as long as what we said in our song, C is the longest side. So I'll put in parentheses. C must be the longest side, the slide side. We call it the hypotenuse. Called the hypotenuse. Okay, and so we're hypotenuse, and these sides are called the legs. And guess what? The legs are interchangeable. Okay, you can call it. We could have made this A and this B, or we can have it like it is. Either way is fine. But C has to be the hypotenuse across from the right angle. Okay, so label the sides and then write the Pythagorean theorem. Pythag theorem. My college professor wrote theorem like this. I liked it, so now I write theorem like that. So I'm going to write the Pythagorean theorem. A squared plus B squared equals C squared. Okay. Now, we need substitute. Sub in values from triangle to, here we go again, theorem. Okay, so A is 7. So I'm going to put 7 here. B is 4. I'm going to put 4 squared. And C is X. I'm going to put X squared. Now, use order of operations to simplify. So that means I gotta, you know what that is. That's the PEMDAS. Remember that? Parentheses, exponents, multiplication, division, addition, subtraction. And here we have exponents. So we're gonna square. We know our squares. We just did that, okay? So parentheses, so I did my exponents. There's no multiplication or division, but there's addition. So 49 plus 10 is 59, plus 6 is 65. And then use inverse operations, solve for x. And what does that mean? We want a square root because we see x squared. It's not writing, there we go. It's square root. And x squared, square rooted is just x. And 65 is not a perfect square, so I'll leave it like that. It's my final answer. Square root of 65. Okay, so let me just read this one more time. Label sides A, B, and C. C must be the longest side, called the hypotenuse. Write the Pythagorean theorem. A squared plus B squared equals C squared. Sub in values from triangle to theorem. That's what I did right here. Use order of operations to simplify PEMDAS. So that's here and here, here and there. That's what I did right there. And then use inverse operations to solve for x. Let's do it again, all right? One more time with a new triangle that nobody has gotten right so far. Now, well, let me do 2 more because you'll see why. So I'm just going to do this one kind of fast here. A squared plus B squared equals C squared. Whoops, and I'm going to label. I see my little box that looks like right angle. Across from that is C, right? So now we're going to substitute 16 squared, 12 squared, x squared. And I know this is 196, 144. Add these together, so that's going to be, I don't know. Can't. These numbers are too large for me in my head. Oh, 340. All right, let's see. Hold on. What is the square root of 340? Oh my goodness. I may have made a mistake. What is 196 plus 144? No, it's 340. All right. So then we're gonna, oh, you know what? But that's not, what is 16 squared? See, that's the problem. 16 squared is not 196. That's 14 squared. 16 squared is gonna be 256. So now I gotta redo everything. Okay, so that's, let me just read that. 256, 144, 0, so that's 10, 400. So now, you know, it's 4, oh my goodness, 400. And I'm going to square root both sides. And this time the square root of 400 is 20. There we go. Okay, so did you see how I messed up? You know, right here, I messed up. And then I found my mistake. It took me a minute, and then I redid my work and got the right answer. Okay, so you can do the same thing. Don't give up on yourself. Okay, so now we have to do this one. Write down this triangle, nice crisp angles, and write the Pythagorean theorem. Okay, now C is across from the right angle. C is a number this time. This time A or B, it doesn't matter which one, but one of those is our variable. So I made it A, okay? So now I'm substituting. So the 3 squared is my B squared. And this is going to change a little bit. So I'm still going to use my order of operations to simplify my exponents. But I want you to slow down and be careful here because notice our numbers are on opposite sides. So we are going to need to subtract the 9 from both sides to get x by itself. 25 minus 9 is 16. Then we square root both sides. X equals 4. Oh, okay? So make a note to yourself. If A or B is the variable, then you're going to subtract. Yeah, I'm going to type that out. It's my handwriting. If A or B is the variable, you will subtract and square root to find your answer. If C is the variable, you will add and square root to find your answer. It's just kind of a little pattern that we see. And even though it's not precise mathematical language, if we're thinking about writing a computer program, this would be very important to know because now we know how to write our code. So let's move on. Let's move on to the next one. Isosceles triangles. This one looks a little tough, but what we need to do is remember we're talking about right triangles, right? So this is not a right triangle, but half of it triangle. This side, so I'm going to take and redraw that. And I see the square root of 13 here. And I see 2 here. And I want to find this side. They already said x is all the way across. So I'm going to make it y. Okay? Now I'm going to write out my Pythagorean theorem. And I'm going to substitute. Oh, I'm going to label my sides. I'm going to substitute 2 squared plus y squared equals square root of 13 squared. I'm going to use order of operations. So 4 plus y squared equals the square root and the squared cancel out. So it's just 13. Now this is the one where I subtract because the numbers are on opposite sides of the equal sign. 13 minus 4 is 9. And I square root. Y equals 3. So that means 3. It's right there, which is right here. But x is not just half the way across. X is the whole way across. So over here, guess what? That's also 3 because these triangles are identical. So x is 3 plus 3. It's the whole way across. 3 plus 3, which is 6. I bet some people picked 3 or didn't know, but now you know. Okay, so this one is just like the other ones, but we need to draw the right triangle before we start. Okay, so here again is the same type of thing. Here, this one will be the last one we do. This, and I see the right triangle. I'm gonna redraw it. And this time, see, 4 is the whole way across. So just halfway is 2. 4 divided by 2 is 2. And that's, okay, so if they give you the whole way, we need the bottom. It's 2. See, I didn't. And x goes right here, and 8 goes right there, right? So now a squared plus b squared equals c squared. 8 squared, x squared, 2 squared, 4 plus x squared equals 64. Subtract 4, subtract 4. I'm sorry if I'm going too fast. I just did this like 5 times already. The square root of 60. Oops. Sorry. Okay. So last problem we're doing for our Edpuzzle video. I hope this is helpful. But if it's not, you're going to make your traffic light problems and we're going to do whatever problems you want in class, right? All right, last assignment. Which side lengths form a right triangle? Which side lengths will be true in the equation a squared plus b squared equals c squared? So that's what it's saying. So a squared plus b squared equals c squared in a right triangle, but not in a non-right triangle. You see? Okay, so we're just doing this one problem here. So pay attention, okay? So A, let's see if that's a right triangle. I'm gonna hope they put the longest side last. It looks like they did. Okay, so 5 squared plus square root of 8 squared equals 33 squared. Is this true? Let's see. 25 plus 8. Is that equal to 33 squared? I really don't think so. I think this is like 33 and this is 33 squared. So this is not true. 33 is not equal to 33 squared. Okay, let's try B. 8 squared plus 15 squared equals 17 squared. Let's see. That's 64. This is 225. 17 squared, I think it's 343. Let me check. What is 17 squared? Oh, it's 289. Look at that. Mr. Field is not.
I have one student at the front desk and he has this not the other.
Yes. Okay. So that's 289. So let's see. Is 64 plus 225. 289. Let's see. 9, 8. Hey, look at that. So 289 when you add those two together, and then 17 squared is 289. You know what that means? These three numbers could be sides of a right triangle. So B is the answer. But C, the last thing we'll do in this video, square root of 2 squared plus the square root of 2 squared, is that equal to 2? Well, the square root of 2 squared is just 2. And again, just 2. Does 2 plus 2 equal 2, guys? No, 2 plus 2 is 4. All right, so I hope that's helpful. Try the assignments, post your traffic light problems, and I'll see you tomorrow.